So maybe you've been out riding around in the car with your parents and you see this type of sign on the side of the road. Well, what does that exactly mean? And you could probably look at that sign and you probably think, oh, that means there's a hill. Truckers should beware. Well, and that's pretty much what it is. That means that there is some sort of hill or an incline coming up, and whoever's driving needs to be extra careful. It's kind of like a caution sign for hills. What it actually stands for, and it's not just for trucks, it's for cars too, what it actually stands for is steep grade. And a grade, not a grade in school like an A or a B, this type of grade is it's the slant on a hill. So how steep is that hill that's coming up, and how careful do I need to be? So if you look and see at these signs, sometimes you'll see something like this, and other times you'll see something like this where they actually put a number attached to it. Of course, that's where the math comes in. So that gives these truckers or drivers an idea of how steep is this hill that's coming up. Well, in this case, if they said 18%, hopefully you remember that percent means out of 100. And we'll talk more about that later. Percent, cent means 100, per means out of. So this means there is a hill that is 18 hundredths or has a slant of 18 out of 100. Well, you might not think that means much, but really it does. That tells that person driving that for every 100 feet you go across, there is a drop of 18 feet down, or a vertical change of 18 feet. So the bigger this number is, the bigger this percentage is, means the steeper that hill is going to be, and the more cautious and the slower you need to take that hill. Well, when we talk about lines, I mean, if you look, that hill on that picture just looks like a line. And we've been talking about linear functions, so there is a term that goes along with linear functions, and that term is slope. Slope is the steepness of a line. It's a characteristic of a line. And that tells you how steep a line is. So you might, as soon as you hear the word slope, I'm sure you're probably thinking of skiing. In skiing, you have a ski slope. You have the bunny slopes, and what makes them bunny slopes are because they're not very steep. They're kind of a shallow hill, so you're not going to go real fast on them, and if you do fall, you're probably not going to break any bones or die or anything. But then when you get to the really, really big hills, when you get really good at skiing, you'll go on a hill that's much steeper, so you'll go down that hill much faster. And those, they call them, like the hill of death or whatever, devil's curve, things like that. All these crazy names because they have an extremely big slope. They are very, very steep, so that means only experienced skiers should be going on those hills. Now, when you talk about slope, obviously, there's some numbers involved since it is a math idea. First of all, to describe slope, we use the variable m. M stands for slope. Now, there's not a great reason why. In fact, it's not been determined officially by mathematicians why m stands for slope, so it's one of those kind of the mysteries of math. There's not too many of those, but that's one of them. And what that means is the way we measure slope is by counting the rise of that line and putting it over top of the run. Now, rise is just the vertical change of that line. So how much does it go straight up or straight down compared to how much you run? And the run is the horizontal change. And if you remember horizontal, like the horizon, it goes across. So if I have a line, let's just take I'll take a line like this, something like this. Let me put a arrow, so it's officially now a line instead of a ray. If this is my line, if I'm measuring the slope of this, I'm figuring out how much, if I start on one point, how much do I have to go up, straight up, and then how much do I need to go straight over again before I hit that line. So that is the rise. That's how much I have to go straight up. The run is how much I go straight across or horizontally until I hit that line again. And if you remember from our linear functions, we had a constant change. There was always the amount that our outputs went up or down by each time in our input-output tables was exactly the same. And that turns out to be our slope. And we'll talk more about that later. But for every so many steps we go up and however many steps we go over, we would continue doing this. And every time we did that, we would hit another point on that line. Let's take a look at some examples. Now, before you get into your actual measuring slope on a graph, let's just take some general ideas here. So first, there's pretty much 4 different ways your line could turn out. It could slant upward from left to right, which means you're starting down at the bottom, down here, and then as you're going up as you move from left to right. From left to right. And that means your slope is going to be a positive slope. So that means as you move up from left to right on your line, that means you are moving in the positive direction. You're going up and you're going to the right. If I have a line that slants down, like the second one here, from left to right, that means I have a negative slope. So as I start at the top, it's going down from the upper left-hand side to the bottom right-hand side of your graph. That's going to be a negative slope, not slop, slope. Okay, you also could have a horizontal line, like this one down here. And if you have a horizontal line, that basically means there's no change. If there's no change, that means your slope is 0. And then last, you could have a vertical line, which means straight up and down. And what that means is if you're rising only and there's no run, that means you have an undefined slope. Which means you can't really put a number on that slope because mathematically it's impossible. And I'll show you why later on. So if you don't understand that last one, that's okay. We'll get back to that later on. Okay, so now let's look at some specific examples here. Let's take this line right here. So before you even start, look at how the line goes up or down. How does it fall? Does it go up from left to right, or does it go down from left to right? We know it's not horizontal. We also know that it's not vertical. So what kind of slope would this graph have? Positive or negative? And hopefully you just said positive. And the way that I know that is because as I move from the bottom of the line to the top of the line, it's going up. So now if I look at some specific points, I can actually put a number and figure out what my rise and my run are. All right, so if you look, I put some points on here, just some dots, so you can really kind of see what the specific points are on this graph. So let's actually count our rise and our run. Remember, slope is rise over run. So let's actually write that in here. M equals rise. Let me try that again. Rise over run. So now let's count. We go from, let's start at, we'll go to the y-intercept. Why not? So here's our y-intercept at -2. Now, if I look, I can see another really good, well-defined point right here at 4, 1. So what I need to know is if I want to go from this point up to this point, how much do I have to go straight up and straight over? And that'll tell me how steep this line is. So I'm going to count straight up. I go 1, 2, 3. So I rise 3, and then I go over 1, 2, 3, 4. And that's my run. If you look, there's another point right here at 8, 4. If I want to get to that point, I'm going to rise 1, 2, 3, and then I run 1, 2, 3, and 4. Same thing down here. Look at this point right here. It's at -4, -5. I rise 1, 2, 3. I go over 1, 2, 3, 4. So what that tells me is that my rise is 3 and my run is 4, which tells me my slope is 3/4. So this line has a slant or a steepness of 3/4, meaning for every 3 units I go up, I go over 4 units. And that will give me every single point. And you should, when you do that, it'll look like you have a little set of stairs on your line. So there you have it. So let's look at the next page and look at another example. So let's take this one right here. You can see we've got some defined points. Look at the dots right here. So I'm going to take this one right here, -6, 8. And I want to get to this point right here, which is -4, 5. So to do that, I have to rise and run. Now, this line is sloping downward from left to right. If it slopes downward, that tells me my slope is going to be a negative number. So I'm expecting a negative slope. So if I go down, that's 1, 2, 3. I go down, and then I go over 1, 2. Now, I went 3 down. Since I went in the negative direction, that means I get a -3 for my rise. My run, I went to the right 2, so that tells me I went in the positive direction. So that tells me my slope is -3 over 2. And that's all there is to it. If I keep doing that, that's my slope. If I keep doing that, I'll get more points. 1, 2, 3, over 2. 1, 2. Keep going. 1, 2, 3, over 2, 1, 2. And there's my y-intercept. I go down 1, 2, 3, and I go over 2. 1, 2. Down 3, over 2. Down 3, and over 2. And there you go. A little sloppy, but I still have all my points there. Now, real quick, let's look at the horizontal. You could take any point on here. It really doesn't make a difference. So if I go to any one of these points, I'm not going to rise any. So that means my rise, forgive my writing, I have to use my mouse. My rise is going to be 0. I rise nothing, and then I run. I could run 1 or I could run 2. It doesn't matter. Every time I run, I'm going to hit a point on that line because I'm not going up and I'm not going down. So 0 divided by any number is what? Hopefully you're answering 0 right now. Now over here, really quick, if I were going to take a point on this, let's take a point right here. I can rise 1, I could rise 2, I could rise 3. I can rise any number I want, but when I run, I'm not going to run any. I'm not moving at all to the right or to the left. So my rise might be 4. I could go up 4. And then I don't go to the right, I don't go to the left, so that means my run is 0. If you tried to punch this in your calculator, 4 divided by 0, it's going to tell you you have an error or a syntax error because it's not possible. And that, my friends, is where we get the term undefined. you can say UNDEF for undefined, and that's as far as you can go.